Can I be heard like this? Is this okay? Simple enough? I'd rather leave the microphone down if people can hear me like this. Are we good? Okay, thank you.
Zoom people might need you to have a microphone.
Zoom people might hear. Again? Okay. I walk around and I'm afraid I'll trip. Okay. Thanks for having me. I'm Geoff Smith. I work at Utah Tech. I'll tell you a little bit about myself. First, I'm not from Utah. I'm from the South, Arkansas, Mississippi, Louisiana public school system. Taught myself how to read, got out of there. Here now, I used to work with turtles and alligators, mainly reptile models. Moved to Utah State up in Logan, and I started doing work in southern Utah with side blotch lizards, the most important lizard in North America. But I work with a couple of other things as well, and just wildlife in general. Utah Tech in St. George, it's an amazing area for wildlife and landscape. So that's why I'm there. It's a primarily undergraduate institution, so I can't just do graduate research with lizards. We do all sorts of wildlife stuff. I have two students with me today, Edwin and Vicente. So thank you for coming. They've helped collect a lot of these data. They're co-authors on here. And Vicente saved my life for this presentation. You might have heard, like, don't let perfect get in the way of good. So I was working on my presentation. I want everything to be perfect. And I wanted to keep working on it, and it was on my laptop, and I forgot my charger on my way up here. So my entire presentation was gone. So I used Vicente's this morning. Vicente primarily speaks Spanish as a first language, so I'm working with a Spanish keyboard, and I'm like, un poco, español. Tengo un poco? I'm not great at Spanish, but what was so much worse about it was that it was like a Mac. And I'm like, this is impossible, even more than the language barrier. So you'll have to bear with me and imagine I'm going to describe things. I don't have pictures, I don't have figures. I'm going to tell you a story about what we saw. First of all, some acknowledgements. Not on this slide, but I have to acknowledge the traditional stewards of the area, and I'm very privileged to hear, along with a lot of us here, some of the stories and traditions. Some collaborators that are not authors. John Taylor at Southern Utah University has helped with some of the bat IDs. Brian Stevens is an entomologist at Utah Tech, where I work. He also runs our museum. Kevin and Jackie, working with the partnership, helped me get out here and get to work. Mark with the BLM, thank you for all of your help with this. There's an anonymous landowner, unless they decide they want to make themselves known, that helped get us to this very secretive site. And also other students, and also my daughter was there to just collect some of the data out in the field. So September 14th, 2024, we collected some aquatic invertebrates, and we deployed a song meter. So this is a box, imagine, if you will, a box like that big, and it's got a wire with a microphone on it, and we zip tied it to a tree next to a spring. So this is a spring. We learned about how water is important in one of the previous talks. This spring, eyeballing it, maybe about as big as this room, right? Is that about right? Maybe a little bit larger. It will probably expand and contract a little bit, so it's not a big area, but it is special. It's special because it's high elevation. Here we're sitting at 5820, 5,800 feet above sea level, something like that. This place is about 1,500 feet higher than that, so it's fairly high elevation, so it's colder than it is right here. It's remote, it's isolated, and it's fairly far from perennial water sources. Now that depends on who you are as an animal and your dispersal capabilities. If you can fly, if you're a bird, like, oh, who cares? You can fly to another state. But some things don't have that sort of dispersal capability. So it's fairly isolated. We know that it's important for wildlife because camera traps have been out there for years, and there have been mountain lions, elk, big charismatic wildlife have been detected in this area. But we collected some bugs. I don't have images of this. Well, not on the slideshow anyway. We had some D-frame nets. We went out and tried to not fall in, and did this kind of swishing sort of pass to try to get the aquatic bugs that were in there. There were dragonflies flying all over the place. So we weren't looking at the things that were out. We were looking at things that were larval in the water in their aquatic life stage. We did that, and then we killed them. We put them in ethanol, and I don't know, there were a couple of remarks on you take something and you give something back. I remember talking with the students about this, like, we're gonna kill who knows how many insects right now, and then we dumped them in ethanol. They had their final cocktail and died. But I made it really clear to all of them that like this was the beginning. We're going to count all of these bugs, and we're going to give back, and our giving back is signifying that this spring is important and learning something about it. So this is part of that process. So that was the bug collection. What did we find? I'll just give you a rundown. We found some true bugs. So hemipterans, Caryxidae, these are water boatmen. We found 2 of those. They're little bugs, true bugs with sucking mouth parts that look like they have oars. You might have seen them. This is where images would be a lot better. And the Ephemeroptera, those are mayflies. Mayflies, a lot of people know what mayflies are. There were 54 baited minnow mayflies and 142 Leptophlebidae. These are prong-gilled mayflies. And this wasn't even in like the most productive time in the season for bug emergences. Lots of mayflies in the water. In the Diptera, so the true flies, we had the chironomids. These are non-biting midges. At least 3 species, don't know exactly how many. If you know anything about aquatic bugs or chironomids, they're very difficult to ID. You've got to like take their heads off and put them on a different sort of slide. It's a pain, so I didn't make my students do that. And then 1 biting midge. In the odonates, these are dragonflies. So there were a couple flying around. These are larval ones that we collected. There were 5 in the genus Gynocantha. These are Asia Darner dragonflies. There was at least 1 sand dragon in the family Gomphidae, and there were 2 Libellulidae, which are my favorite, but everyone has their favorite. So those were the bugs. How did they get there to this remote spring? All of these can fly. Even the water boatmen, these are flyers. We also found amphipods. If you don't know what an amphipod is, you probably know what an isopod is. You all know like a roly-poly? So imagine, if you will, a roly-poly, but instead of being dorso-ventrally flattened like this, it's laterally flattened like that, and it's aquatic. They don't fly. You like throw a roly-poly, it will not fly. How did those get out there? Very far from any other water source. It's not connected to a river. Any ideas how they got there? Yes?
The wind.
The wind? Wind dispersed? Roly-polies, aquatic
On
roly-polies?
shoes?
Shoes?
On animals.
On animals?
Animal poop.
My leading thought whenever I see like a desert tortoise in a weird place is when it was a baby, a raven probably picked it up and flew it way over. I found a paper this morning as I was thinking about this, about waterfowl dispersing amphipods across great distances. They'll get in their feathers. I don't know how they got here, but that would be my idea. Bats, we'll talk about bats. We left the bat meter out for exactly 26 days. Does anyone know why we would use a 26-day cycle for bats?
Lunar cycle.
It's how long the batteries lasted. And then we collected it and we were done. There were 17 species that we recorded. There are 18 species of bats in Utah. Now the bat meter and the app, it lists 19, but one of those is the California fringe myotis, or the California leaf-nosed bat. And those are like Mojave, Sonoran bats. I looked on iNaturalist this morning. No instances of them ever being detected in Utah, but the app says that they could potentially be here. We got everything known to be in Utah except for the spotted bat. I don't know what's up with them, but everything that you could find just about is here. We found it in less than a month, in kind of a cooler time of the year. So this site is diverse. This spot is important for bats. There have to be cliff areas nearby where they can roost. Lots of these have specific roosting requirements. Who do we find? If you know anything about birds, you might know like the 4-digit code for birds. Bats have a 6-letter code. So we have the pallid bat, that's probably my favorite. Cave myotis, long-legged myotis. 17 species of bat. Bat activity is something else because the way these meters work is they're just recording sound. And bats have different frequencies, and then they have different ways of singing within that frequency as they echolocate and move around. And this is distinct by species. So you can also see, like, if there are 2 bat calls or 3 bat calls. Some nights there were over 1,000 bat calls. Does that mean that there's over 1,000 bats? Could be the same bat getting really excited about something. So I'm really concerned about pseudo-replication as a scientist. I don't want to say that that's like a greater abundance. So we can talk about species richness, the different species, but then there's activity. I've called it like battiness, like how batty is this site? Because if they're really active, that is meaningful as well. We know that activity and the presence of species, it changed over time. About 10 days in to our recording, canyon bats and Mexican freetails, which were like the most abundant at the time, they disappeared from the site. And at the same time, like the next day, 5 myota species came in with a similar abundance to those other 2 species. Why would that happen? Like, riddle me that, Batman. I don't know. I don't know why it would happen. My suspicion is that it's just the way that these species migrate in this area in this time of year. Lots of these bats are migratory. But it could be that there's inter-specific competition at this site. I don't know. My conclusions is that this place should be protected. It is recently protected. If you're a spring out in the middle of nowhere, what is the biggest risk to you? I work for Utah Tech University. I'm a public servant of the state of Utah. I think new legislation says that I can be like publicly executed for bad-mouthing cattle. Cattle are like a major problem. In an area this big, you get 2 or 3 cows in there rolling around, they can wreck it. They can ruin it for years. So there is a fence that's around it now, a high voltage fence. And last I heard, it's doing a pretty good job keeping the beef where it belongs. So that's good. What is next is more analysis. The way that we can delve into these data, they're time-stamped. And we can see what's happening at different times of the night for these different species of bats and how they might interact with one another. Are there some species that are never around when one species is? Those sorts of things, but we've got 17 species, so there's a lot to play with. For aquatic inverts, I would like to do some spring and summer surveys. This was in September, it was getting cool. It was after lots of emergences. I'd like to know more about what's going on. Still a little bit cool right now, but in a couple of months, I'd like to come back out and learn some more. I'd also like to look at the relative sensitivities of these invertebrates. So water quality is often measured by aquatic invertebrates because they have different sensitivities to toxins and things like that. I would just like to use those same metrics that like the EPA uses and see what's going on here. I don't know if it'll be that important. I think that it'll probably be more important just to know who's here because it's a weird place. And most of the things that are there are probably there just because of like artifacts of dispersal. But I don't know. The bats, I'd like to look at that throughout the year a little bit more as well. And again, like I mentioned, just more observations to see what's going on among the bats. What are they doing with each other? That's all for this talk. I wish that I had some pictures. Apologies. One shameless plug I'd like to put up is May 7th through the 10th. We're doing Iguanathon in the St. George area. So desert iguanas like only live in the Mojave, and it's a big community science sort of event where we march north up the Beaver Dam Watch, and we should find the northernmost desert iguana in the universe. It's like at the very edge of the range. So if you're interested, you can find me at my name, jeffrey.smith@utahtech.edu. That's all. Thank you.